So the first thing we want to do always is check to see if there's a number that I could divide out evenly. So all of these numbers are even numbers, which means they're divisible by 2. In other words, if I say 2 times some stuff, I can get this here. So I think to myself, oh, this should be n squared. Did you guys know that was n squared? All right, sorry. That should have been n squared. Uh-oh, Mr. Adams made a mistake today. So anyways, you might have to redo this whole problem. Sorry, my bad. So what do I multiply 2 by to get 2n squared? Just n squared, right? So I'm thinking, in my mind, I'm thinking, okay, I multiply this by this to get this. So then the next thing is, what do I multiply to get negative 4n? In other words, I'm saying 2 times this should equal this. In that same vein, what do I multiply by 2 to get negative 70? Negative 35. Okay. So now this 2 right here is just going to go here, and I'm going to have some stuff like this, because I'm just going to factor what's in the parentheses. So now this, I'm only going to do the stuff in the parentheses. And so I'm going to take this first term, which is n squared, and this last term, which is negative 35. And I have to remember that these two other terms, this and this, have to add up, or you subtract, however you want to look at it, but they have to add up to negative 2. So n squared is pretty easy. You're just going to do n times n. What two numbers will I multiply to get 35? 7 and 5. And then we have to decide which one's positive, which one's negative. Yeah, the 7 would need to be negative because that's how I end up with the negative 2 when I add these two up, right? So I end up with n minus 7 times the quantity n plus 5. This is what we call prime factorization. Now in front-end loading, really what I'm trying to teach you today is just how to factor. But I keep throwing these terms at you. Prime factorization means that we factored it till it can't be factored anymore. In other words, we pulled the 2 out. If you forgot to pull the 2 out, the numbers would be the same. The zeros would still be the same. They'd just be bigger numbers. Okay, one of these would be like 2n minus 14. Or you'd have 2n plus 10. It depends on how you do it. So anyways, how do I double check my work? Yeah, we got to plug it in. So I'm going to plug it in. So give me a second. I got to look at this on the other screen. Well, just tell me what it was. It was 2. It was like 2 x minus 7 and x plus 5, right?
Yes.
I mean, it doesn't matter if we have them in a different order, but I think that's how we had it. And so then the original equation was 2x, but it was actually 2m, but I had to, minus 2x minus 70, right?
It was 4x.
Oh, 4x. That explains why it doesn't match up perfectly. And I'm going to zoom way out. Is somebody knocking at the door? Okay. You guys are just tapping on your desk. You're like, I'm doing math. All right, let's take a little screenshot of that. All right. So if I take n minus 7, set it equal to 0, and I add 7 to both sides, I get n equals positive 7. If I take n plus 5, set it equal to 0, subtract 5 from both sides, I get n equals negative 5. That's what these are. What are the names for these things that we just found? Yeah, zeros. in this particular case, we call them zeros because we set them equal to 0, but they're also the solutions. They're also the roots. They also happen to be the values for x or n where it crosses the x-intercept. I said n here, but if we put an x there, that would be an x-intercept, right? And by the way, it doesn't have to just be x and y.